Welcome. In this video I'm going to show you how you can perform a one-sample trinomial test using Microsoft Excel. Um, I won't be using my own add-in, which actually has a function that can straightforward do this. In this video I'll simply go over how you can perform it from scratch. This test can be used as an alternative to a one-sample Wilcoxon signed rank test or a one-sample sign test. And the test actually uses a so-called multinomial distribution and specifically a trinomial distribution. Now I have some numerical data. This is a little bit more tricky if you have non-numerical data, then you first convert them to ranks. But in this case I've already done that and I simply have scores from 1 to 5. My hypothesized median is going to be 3. And the first thing I need to do is I need to specify, let me zoom in a little bit, might be easier. I need to specify the sample size, which is simply now the count of all the values in A. Be careful if your column header is actually a number, because then you need to subtract 1. Now the first thing we need is the number of scores that were tied with the hypothesized median, so you can use count if and then simply select the hypothesized median. Note that I'm using a semicolon to separate parameters. In your version of Excel that might be a comma. The number of positive scores is simply counting if the value is greater than the hypothesized median. So use a greater than sign between quotation signs and then the and sign. Similar for the negative one, but then a less than. We also calculate the probability of having therefore such a zero difference. So that's simply the number of zero differences divided by the total. So that's simply this one divided by that one. We can then say, well, and this is what we're going to be using as our also as our proportion for the population. Now for the positive and negative differences in the population, we're not going to be using these two, but we're actually going to divide everything that remains after we subtract this, in this case 22%. So I'm going to say 1 minus this 22% and then divide by 2, 1 for the positive and 1 for the negative. This way these three should add up to 1 again, as you can see over here in very small at the sum. Alright. Then we determine the absolute differences between the negative and the positive ones. So we can simply say this one minus that one and take the absolute value. Now what we want is the probability of a difference such as that 16 or even greater. And for that we can finally start using the multinomial distribution, and specifically because we have three values, the 0, the positive and the negatives, it's a trinomial one. I'm going to scroll down a little bit so you can see this is the formula that we actually need to fill out. This is the trinomial part, and it's not going to be a cumulative one because we're specifically interested in a difference of, in this case it was, what was the difference, 16 or more. The largest difference would of course be the sample size, so that's why this is summing up from ND to N. We have quite some work to cut out for us, so first we'll simply let Z run from that 16 to N, so 16 to 54 I think it was in our case. I've done that over here and I simply let it run. However, as you can see, the first one is fairly easy. The next one actually has to check if this one is up for a change. So you'll see I have a slightly different formula there. It's going to be a checking if I'm actually at the maximum for my index, and otherwise it will shift. So this, once it hits the 19, this one actually goes one up. And this goes all the way down, all the way to, oh, I've done it a little bit too far. It should go, let me just scroll down to 54. Oh, there we go. I copy pasted the formulas even further down. I didn't have to do that, but the if parts are just there so it doesn't do anything if it's empty. Alright, Then let's each I index run from 0 to, and then we divide everything of n minus z and then divide it over 2. So that's going to be here. The index is going to be 0 all the way up to, and then n minus z divided by 2. So in this case, all the way up to 19. And that's the I max actually. All right. Then our next one would be so that's that part. The G column shows therefore then the index. So this is the maximum index. That's simply this n minus this one divided over 2, and then this one simply checks if it doesn't, it starts at 0, and everything after that it simply will say, well, if this one plus that one becomes higher than this one, then you put in a 0, and otherwise you just add the add 1 to the previous one. These indexes are actually what we're going to be using each time as our number of positive differences. Alright, so we can use that one. Then the number of negative differences is going to be that one minus the z value, plus the z value. So we're simply going to do the z value plus the number of positive differences. Positive difference with the hypothesized median. That leaves this one plus this one plus this one should be in total again the sample size. So we can say the sample size minus and then the other two. I could actually also simply do it like this and makes perhaps slightly more sense. And then copy paste that down. It doesn't change the outcome. Alright, and then we start filling out the bigger parts. In this long scary formula, you might notice here there's a gamma, which is a Greek letter, and that's a function that Excel luckily has available of the number of positives plus 1. So that's simply being done over here. We're doing the gamma function of this one plus 1. The next one is the same for the negative and the same for the 0 differences. So that actually takes part of the denominator of all of this. Then in the upper part we have, as you can see, these three, which are the probabilities, and then raised to the power of the number, so corresponding number. So we have our probability of the positive differences, which we had all the way over here, and then we simply raise that to the power of the number of positives. We do that for each three. And then finally the trinomial one is going to be simply we multiply those three positive ones with each other. You can use a product formula for that, but we also have in the numerator this gamma of n plus 1, so that's being added over here. We then divide everything by the product of the other three, and that should give us the trinomial probability. We copy all of these down, and that's most of the work that's finally done. The last thing we need to do is actually sum all of those up. So here you can see it's simply a sum of those, and that eventually then gives us the result that we were after. Alright, in this case it was below 0.05, so we would reject the null hypothesis and would conclude that there is a significant difference with the hypothesized median. I hope this video was helpful. With my add-in stikpet it can go a lot easier. There's a simple function that can do it, but if you don't want to use that, here's one way of doing it without that. Alright, thanks again and hope you enjoyed the video.